Okay, so in the previous video we talked about this idea of significant figures, which is basically just the sum or the total number of digits that you get when you're making your measurement. So remember that if I were making this measurement with the burette, and I noticed that the volume is 25.68, then I have four significant figures in my measurement. Whereas when I'm making a measurement with the ruler, in this case I only have three significant figures. Now, what exactly is the importance of the significant figures or significant digits? It really is a measure of reliability, okay, of these glasswares that you're using. So if you think about a beaker, for example, the numbers that are listed on the beaker is out of 10. So for example, you have 60, you have 70 here as the middle marker, you have 80 here. So it's plus minus 1 milliliter, where 1 is your estimate, right? You can say it's 75, for example, but really you're only sure of the 7. The 5 is your estimate. Or in this particular case, if you look at this volume, it's between 40 and 50. You might say it's 47 milliliters, but the 7 is really uncertain. That's your estimate, whereas the 4 is certain because that's the part that's listed on the beaker itself. With a graduated cylinder, you have a higher reliability because if you were to look at those two numbers, again, now it's between 35 and 36, right? Because the next line here is 36. The meniscus is right there, so you can say it's 35.5 maybe. But you have an additional reliability that's 0.1 in the 0.1 milliliter range. Okay, so it's 35, and so it's the first decimal. And then in the beaker you have, or I'm sorry, this should be the burette. Let me correct that real quick here. That should be the burette. In the burette, you have an additional reliability because now you can read off to the second decimal. So you understand, hopefully, that at this point that the number of significant figures you have actually tells you something about how reliable that measurement is. You can read, the more significant figures you can read, the more reliable the measurement is because you have you're more confident of the number, right? Because you know that, for example, in the case of the burette here, that the volume, if you look at this carefully, the volume is between 20.3 and 20.4. So you know for sure it's 20.3, perhaps 20.39 in this case, or 20.38 milliliters. The same volume, if placed in a beaker, would be somewhere between 20 and 30, so you might say it's 25, but it's very different than 20.35, okay? So you notice that it's, or 20.38 in this case. So it's very different because the more numbers you can read, the more certain you are that the volume is, between 20 and 21. Earlier, if this same volume is placed in a beaker, you would not have as big of a confidence, okay? So the rest of this video is just on significant figures and how to count and how to use them in calculation. These are really things that you should know already from your prior course in introductory chemistry. So I'm just going to mention a couple of things here. Remember that this is how you count significant figures. So if you have significant figures in your measurement, you need to count them. You need to know these rules. The particular ones that are important is really when it's related to zeros, because certain zeros are counted as significant, whereas other zeros are not counted as significant. So you have to kind of think about, remember all of these rules. Again, you can read them through. I'll have a couple of maybe one or two questions in class about significant figures that you can practice on. Okay, but the homework assignment also has significant figure questions. In calculations, you just have to remember that for multiplication and division, you keep track of the least number of significant figures. That's what your final answer should be. Whereas for addition and subtraction, you keep track of the number of decimals you have, and your answer should be limited by the least number of decimals. And lastly, very quickly, on rounding rules. Remember that a lot of times we have to round in a series of calculations because you don't want to just have a bunch of numbers, okay? So one of the things you need to keep in mind is always, what is the difference between calculated numbers, which is the one you get off your calculators, and rounded numbers. So let's say you have 2.78956 7 grams per cubic centimeter, okay, or milliliter, let's say, is your calculated density value. Now, as it turns out, when you're making your mass measurement and your volume measurement, you're limited by the volume measurement, and you're supposed to only have 3 sig fig in your final answer. Then, of course, the correct answer here would be 2.7, and you can only have 3 numbers, 3 sig fig in this case, so you have to round that last number here based on the number that follows it. So the number that follows it is 9, so this 8 rounds up to 2.79 grams per milliliter. Okay, I want to mention to you that, when you want to round a calculation, keep in mind that you really don't want to round until the last step of the calculation. So let's say you have to do 2 or 3 different steps in calculation before you get your answer. Make sure that you don't round the in-between steps. Okay, you just keep going until you get your final answer with a lot of digits in them, and then you round to the appropriate significant figures. Okay, this is always the rule when doing chemistry calculation. Just keep that in mind. Don't round in the middle, in the intermediate steps, but keep going until you get to the final answer before you round. Okay?